Namaste, dear students. Welcome back. So I'm back with the class that is quantitative techniques. So in the last class, I had given a homework for you to identify the log and anti-log values for this. So I believe you have done, and I'm showing you the answer. So this should be the answer for log and anti-log. I hope you have identified by yourself and you got the correct answers. Okay. Fine. So in today's class, so let us learn few properties of logarithm. So we are speaking about properties of logarithm. So what is that properties, how that work? So number one, so that is log 1 to any base. Log 1 to any base is always equal to 0. For example, log 10 to the power 1, that is equals 0. Log 2 to the power 1 equals 0. Log 5 to the power equals 0. So any number that is 1, power is 1, that is always is 0 to the any base. Clear, it might be any number, any base if you have, and the power is 1, so that value is always 0. And second one, important one, you should know that log of a number to the same base is always 1. Log of a number to the same base is always 1. So that means let us go with an example so that you get clarity. Log 10 to the power 10, that is equals 1. Log 8 to the power 8 equals 1. Log 5 to the power 5 equals 1. Clear? See, when you have power and base, when both are same number, so that is always equals 1. Okay, so these are the two important properties which you should know before solving the problem. Okay. So next, let us have few observation about laws of logarithm, so that you must know about it. So let us go with the laws of logarithm. So how this works? Laws of logarithms. Laws of logarithms. So very important. Without this we cannot solve problems, so that you should know. So number one, law of logarithm is log a to the power mn. Log a to the power mn is equal to always log a to the power m plus log a to the power n. Log a to the power m plus log a to the power n. So we can go with an example for this is log 2 to the power log 2 to the power 2 into 3. So that is equals log 2 to the power 2 plus log 2 to the power 3. Okay, this is first law. second law, log a to the power m divided by n. So that is equals log a to the power m minus log a to the power n. Okay, I am giving an example here. So that is log 10 to the power 4 divided by 5. That is equals log 10 to the power 4 minus log 10 to the power 5. Understood? Fine. So now I am going with the third one. Log a to the power m whole power n. That is equals n log a to the power m. I'll give an example for this so that you will get a clarity. That is log 4 to the power 3 to the power 8. That is equals 8 log 4 to the power 3. Understood? Or do you have any confusion? So if you have confusion, just practice this 2 to 3 times so that you will able to understand. Okay, so let me go further. So next I am going fourth law, that is we call this as a change of base law. Change of base law, that is log a to the power n equals log n divided by log a. So I'll give an example for this. Log 4 to the power 2. See, whenever he has not given a base value, so what we will do, we will have a assumed value, correct? So here we'll have an assumed value. So how this work, that is log 10 to the power 2 divided by log 10 to the power 4. Okay, clear? Fine. So next we'll have how we are going to write it in the logarithm forms, so that you should know. Let me write the following. Expressions in the form of logarithm, the form of logarithm. So that is number 1, 3 to the power of 2 equals 9. So how we are going to write this? How we are going to write this in a log form, that is log 3 to the power of 9, that is equals 2. Just check out, log 3 to the power of 2 is 9. So here log 3 to the power 9 is equal to 2. That is how we have to write. Able to understand, right? 2 to the power of 4 equals 16. So that has to be written as log 2 to the power 16 equals 4. Clear? The same way 4 to the power 3, that is equals 64. So it will be written as what? Log 4 to the power 64 equals 3. Okay, I'll write few more examples so that you will get an understanding thoroughly. Log 10 to the power minus 2 equals 0.001, that is equals log 10 to the power 0.001, that is equals minus 2. Okay, See, this is what converted values I am writing. Okay, so we write these expressions in logarithm logic. So next, fifth one, 2 to the power of minus 3 equals 1 divided by 8. So that is log 2 to the power 1 by 8 equals minus 3. Next we have sixth one, 10 equals 10. That is log 10 to the power of 10, that is always equals to 1 as per the properties of logarithm which I have taught you in this class only, in the beginning of the class. Now this we have written in logarithm form, correct? Now we will have like write the following in index form. So if you write the following in index form, how it reflects: log 8 to the power 64 equals to. So if you convert this reverse, so this is log form. So now we have a log form here. We have to convert it into reverse. So that becomes 8 to the power 2 equals 64, correct? Second one, log 3 to the power 81 equals 4. So that is 3 to the power 4 equals 81. Next, log 2 to the power 1 divided by 16 equals minus 4. So the answer is 2 to the power minus 4 equals 1 divided by 16. 1 divided by 16. Clear? Or do you have any doubts? Clear, right? Okay. Let us solve one or two problems so that you will get an idea about that, how it works, and how we are going to consider a few expressions in the while solving the problem. So these are all basic problems you have to learn. So number one, it is not logarithm, we are not using log table, it is a basic problem. So April, May 2007. For 2 marks they have asked. That is, find the value of log 2 to the power 32. Log 2 to the power 32. So for this you have to answer, let log 2 to the power 32 be x. Okay. So then our expression is, what we are going to do here, 2 to the power x is equal to 2 to the power 5. Why? Because 2, 3, 4, 5. So that power value 5, 32 if you convert. So that becomes 2 to the power 5. That 32 value is, okay. So this, so I am converting 2 to the power x equals 2 to the power 5. Because when you do 2 into 2 into 2 into 2, 1, 2, 3, 4 and 5. So that is going to be 32. Clear? So then 2 to the power x equals 32. So here when bases are equal, the powers can be equated, correct? So when bases are same, this I am speaking about. When bases are same, powers can be equated. Powers can be equated. Okay, so by looking into that, therefore x equals 5, that is equals log 2 to the power 32 equals 5. So our answer is log 2 to the power 32 equals 5. So next problem number 2. Find the value of log root 5 to the power 25. Okay, so now let us take log root 5 to the power 25 equals x. Okay, so when you have this value, that becomes 5 to the power x divided by 2, 1 by 2, right? So that is x divided by 2 equals 5 to the power 2, because 25 you are going to get 5 into 5, that is 5 5s are 25, so 2 times if you multiply. So when bases are equal, powers can be equated. Since bases are equal, okay, so powers can be equated. So let us equate the powers now. So that means root 5 to the power x equals 25, correct? So when you remove the root, that becomes 5 to the power 1 by 2 whole power x equals 25. So that means 5 to the power x ones are x divided by 2 equals 25. So that means what? Therefore x divided by 2 equals 2, correct? So that means 2 2s are 4, so x equals 4. So that exactly means log 5 to the power 25 equals 4. This is how you have to solve. This is exactly based on indices, which you have already learned in the previous video, okay, which I have already taught you in the previous video. So let us solve one more problem. Find log 5 root 3 to the power 75 equals x. So now what we can do here, we have to convert it. So that is 75 1 divided by 2 whole power x, that is equals to 75. That is equals to 75. So that means 5 root 3 whole power x equals 75. Okay, so here if I convert this 75, x ones are x divided by 2 equals 75. So in the next you have bases are equal, powers can be equated. So by applying that, so we have to equate the powers. Before that, let us go here and complete it. So that is 5 as 2 is there, so that becomes 25, correct? So that is root 25 into root 3 whole power x equals 75. Okay, so in the next level, 25 root into 3 whole power x equals 75. So that becomes 25 3s are root 75 whole power x equals 75. 75 x 75 to the power x equals 75. So now here applying this step over here, that means 75 1 divided by 2, because I am removing the root, whole power x equals 75. I am applying this now. Okay, so 75 x 1s are x divided by 2 equals 75. So now the bases are same. Bases are same. So powers can be equated. So equate the powers. So that means what happens? 75 x by 2 equals 75. So that becomes x divided by 2 equals 1. So that means x equals 2, that is equals log 75 equals x 5 root 3. Okay, that is exactly x2 equals, this I have written wrongly, that is 5 root 3 to the power 75 equals x. Okay, fine. So next one more problem, same kind. Find the value of log 4 to the power 1 divided by 64. 4 to the power 1 divided by 64 equals x. So 4 to the power x equals 1 divided by 64. So that means 4 to the power x equals 1 divided by 4 to the power 3, because if you multiply 3 times, so you will get 64. 4 to the power x equals 4 to the power minus 3. I am removing this one. So when bases are same, powers can be equated. So that means x equals minus 3. So which we can prove that log 4 to the power 1 divided by 64 equals minus 3. That is equals minus 3. Okay. So I believe you have understood a little bit about these, because I'm applying here purely all kinds of index form of problem, so which is more of index. Solve for x log 9 to the power root 3 equals x. So then what I have to do here, 9 to the power x equals root 3. So that means 9 to the power x equals 3. So 3 to the power 2 is 9. 3 to the power 2 to the power x equals 3 to the power 1 by 2, because I am removing the root. 3 to the power 1 by 2. So that becomes, when bases are same, powers can be equated, correct? So 2x equals 1 divided by 2. So that is 2x 1 divided by 2. 2 2s are 4x equals 1. So that is x equals 1 divided by 4. So that is nothing but, therefore, log 9 root 3 equals 1 divided by 4. So this is the answer. This is the answer. Understood? Fine. So I'll go with one more problem. So that is sixth problem. Find log root 2 to the power 8. So then log root 2 to the power 8 equals x. So that means root 2 to the power x equals 8. So 2 to the power 1 by 2 whole power x equals 8. 2 to the power x 1 is x by 2 equals 8. Correct. So 8 if you find. So how many times you have to do the power? 2 to the power 3. So 2 to the power x by 2 equals 2 to the power 3, right? Yes. 2 2s are 4, 4 2s are 8. So next step, in the next coming step, what you have to do, because bases are same, so x divided by 2 equals 3. When bases are same, powers can be equated. So now 2 3s are 6. So x equals 6. Therefore, x equals 6. Correct. So that is equals to log root 2 to the power 8 equals 6. Okay, so we'll stop here. In the next class we'll start few more problems, so advanced level. Then you can understand with a few more problems, so better. So then once you able to do this kind of problem, then what we can do is we can go for this log table kind of problem. Okay, so first we will finish off basic problems, few basic problems with the log. So we'll stop here.